Okay, well students, we are in the last session of our calculus, in fact differential calculus, which is concerned with Lagrange's mean value theorem. The last article was with Rolle's mean value theorem. This is Lagrange's mean value theorem, and we are in perhaps class number 40. And whatever this is concerned to PUC second year, keep that in mind. Next we have Lagrange's mean value theorem. Short form LMVT. Lagrange's mean value theorem almost identical to Rolle's theorem except in one condition. In Rolle's theorem we had f of a equal to f of b, whereas here f of a will be different from f of b. That is, in particular, f of a will not be equal to f of b. Remaining conditions resembles exactly same. That is concerned to Rolle's theorem. The right statement of Lagrange's mean value theorem. Let y equal to f of x be the function defined on the interval a comma b, defined on the interval a comma b, satisfying the conditions these are the conditions adopted in Lagrange's theorem. First one, continuous, means function is continuous on the closed interval AB. Second, differentiable, on the open interval AB. Third one, in Rolle's theorem, third condition was f of a equal to f of b, but in Lagrange's theorem, f of a will not be equal to f of b. F of a not equal to f of b. So if any function defined on the interval a b, if it satisfies these three conditions, then this kind of result will be 100% followed. Then comes only when these conditions are satisfied. Then there exist, means we can able to find. Then there exists at least one value for x, say x equal to c, and like in the Rolle's theorem, here also as well c belongs to open interval AB, for which for this value of c. In Rolle's theorem, we had condition f dash of c equal to 0, whereas in Lagrange's theorem, we have this type of condition for which f dash of c equal to f of b minus f of a divided by b minus a. We don't have the proof of Lagrange's theorem. Actually, if it were a proof, Lagrange's theorem can be proved using Rolle's theorem, but don't bother about that proof, which is not prescribed for the second PU course, which syllabus. That means what Lagrange's theorem says that if any function satisfying these three conditions, we can get minimum one value of x, that is c, and to find that c, this kind of equation to be taken, and the equation contains f dash of c as well as f of a value, f of b value, and all these mathematical expression to be satisfied to get c value. Minimum one value, there can be as many as number of values of c which can satisfy Lagrange's mean value theorem. This is analytical. Let's study geometrically how does Lagrange's theorem can be discussed. In Rolle's theorem, geometrically we see that at point x equal to c, there will be a tangent such that it is parallel to x-axis. Let us see in Lagrange's theorem how that geometrical meaning can be described. Observe here. First condition, continuous, means graph of the function smooth, not having any kind of break or gap in the interval a comma b. Second one, differentiable, means f dash x exists, means dy by dx exists, means slope of tangent exists. That means tangent exists. There exists tangent at every point in the open interval a comma b. If there are 100 points in this interval, at every point there will be tangent for this curve. That's the second condition meaning. Third one, f of a not equal to f of b. In Rolle's theorem, we had f of a equal to f of b. That's why what we had is that in Rolle's theorem, end points of curve are at same height from x-axis. What I am writing this is concerned to Rolle's theorem. Here you can find that f of a equal to f of b, but that is restricted to Rolle's theorem. Whereas in Lagrange's theorem, f of a not equal to f of b. That means obviously end points of curve different height from x-axis. So this is an approximate b. This is point x equal to a. This is point x equal to b. And this will be obviously f of a, means y at x equal to a. This will be f of b, means y at x equal to b. You can observe that f of a not equal to f of b. After satisfying all these conditions, now there exists at least one point in between a and b. That point is c. So this is point x equal to c. And at that point, what we have is that f dash of c equal to f of b minus f of a divided by b minus a. Now, let's study this geometrically, what it actually gives me. What's the meaning of f dash of c dy by dx at x equal to c? Right hand side, f of b means y at x equal to b minus f of a means y at x equal to a divided by b minus a. Further, dy by dx means slope of tangent. Slope of tangent at x equal to c equals to, actually interval, What is interval a comma b? Let us treat this interval for a moment as x1 comma x2. That will be easy to understand the student's mind. With setting interval as x1 to x2, obviously y at x equal to b means y at x2, that becomes y2 minus y at x equal to a becomes y1 divided by b means x2, a means x1. Now I hope your mind is now definitely undergoing with one kind of surety that this kind of expression already we have noted, that is in PUC first year geometry, slope of line joining of 2 points. It is exactly expression for slope of line joining of 2 points. Suppose this is point A, this is point B. That means it is as good as the slope of AB. So what we got at the end? We got slope of tangent at point x equal to C. So this is tangent at point x equal to C. And slope of tangent at point x equal to C equal to slope of line AB. Whenever slopes are equal, we know that in geometry lines must be parallel. That means this is line AB as good as chord AB. Now chord AB, tangent are parallel at point x equal to C. That's the outcoming geometrical meaning of Lagrange's mean value theorem. That means geometrically by Lagrange's mean value theorem, what we can assert is that among a number of points there is at least one point x equal to C at which tangent always parallel to the chord joining the end points of the curve. One end point A, another end point B. Whereas in Rolle's theorem, what we had is that tangent was parallel to x-axis, whereas in Lagrange's mean value theorem, tangent will be parallel to the chord joining the end points of curve. Now, it's quite obvious that Lagrange's theorem can be transferred to Rolle's theorem if at all f of a and f of b coincide each other, means become equal each other. That means f of a minus f of a becomes 0, f dash c equal to 0, nothing but Rolle's theorem. So Rolle's theorem can be taken as particular case of Lagrange's theorem. In particular, if f of a equal to f of b, then obviously Lagrange's theorem switches to Rolle's theorem. So there is much more, there is no much the difference between Rolle's and Lagrange's. In Rolle's theorem, two things are important. One thing, f of a must be equal to f of b, and to find c, use the equation f dash of c equal to 0. What I am telling, this is concerned to Rolle's theorem. Whereas for Lagrange's theorem, f of a will not be equal to f of b. And also to find c value, we use the equation f dash of c equal to f of b minus f of a divided by b minus c. As I told in the student class, there will be a word in question like examine mean value theorem. It may be Rolle's or Lagrange's. If f of a equal to f of b holds, take it as Rolle's. If f of a not equal to f of b holds, take it as Lagrange's mean value theorem. And again I repeat, geometrically, for Lagrange's theorem, what we can assert is that at point x equal to c, there is a tangent which is parallel to the chord joining the end points of the curve. There can be minimum one point, there can be as many as number of points like this. There can be as many as number of points where tangent can be parallel to the end points of curve joining. Minimum one point. maximum there can be, in fact there can be as many as number of points. But as many means don't think of 100 or 200, at the most 2 or 3 depending on quadratic, cubic, by quadratic expression of given function. And method of solving problems of Lagrange's theorem exactly similar to Rolle's theorem. Only thing in Lagrange's theorem we use the formula f dash of c equal to f of b minus f of a divided by b minus a, whereas in Rolle's theorem we used the formula f dash of c equal to 0. If you want, we can draw this figure neatly once again. This is called AB. This is tangent. Tangent at x equal to c. This point is x equal to c. Abscissa ordinate y of c. This is one end point of interval x equal to a. This is another end point of interval x equal to b. What we can observe is that tangent, chord are parallel because their slopes are equal because of statement of Lagrange's theorem is in that fashion. We now let's work out problems concerned to Lagrange's mean value theorem. Working method of Lagrange's mean value theorem at given detail for Rolle's theorem exactly similar to Rolle's theorem. Only thing for Lagrange's theorem f of a will not be equal to f of b, whereas Rolle's theorem f of a equal to f of b. And in Lagrange's theorem, use the formula f of b minus f of a by b minus a to find c, whereas in Rolle's theorem, use the formula f dash of c equal to 0. The right problems related to Lagrange's mean value theorem. First problem. It will be the question like verify mean value theorem. It may be Rolle's, it may be Lagrange's. That you will decide depending on f of a, f of b values. First question. First problem. Verify mean value theorem for the function. Verify mean value theorem for the function f of x equal to x square on the interval 2, 4. Write solution. Write solution. Here a 2 b 4 and f of x as defined x square. Let's find f of a means f of 2, that is 2 square, which is equal to 4. Now we shall find f of b, that is f of 4 means 4 square. 4 square will be 16. Observe keenly, correctly, carefully. What we can observe is that 4 not equal to 16. In particular, f of a not equal to f of b. Mention that clearly. F of 2 not equal to f of 4. means f of a not equal to f of b. As f of a not equal to f of b, we have to apply Lagrange's theorem but not Rolle's theorem. If f of a equal to f of b, then you must apply Rolle's theorem. The next we shall find f dash x, differentiating one with respect to x. F dash x equal to 2x. Because x square differentiation is 2x. And also which implies the f dash of c equal to 2c. Observe whether this becomes a valid or invalid. It becomes valid for any value of x in the interval 2 to 4 because it do not have any denominator expression. That's why f dash x exists. Now write clearly f dash x exists. What's the meaning of f dash x exists? Fx is differentiable. Therefore, f of x is differentiable. And for differentiability, take the open interval. Differentiable on open interval a comma b. But standard theorem says what it says that every differentiable function is always continuous. Therefore, f of x is continuous on closed interval a comma b. Let's apply Lagrange's mean value theorem by LMVT we have. Means by Lagrange's mean value theorem we have. What we have? F dash of c equal to f of b minus f of a divided by b minus a. F dash of c means 2c, f of b means f of 4, f of a means f of 2, b 4, a 2. So now 2c equal to f of 4 16, f of 2 4, 4 minus 2 2, or 2c equal to 12 by 2, or 2c equal to 6, because 2 6 are 12. Again 2 can be easily cancelled out, leaving out c equal to 3. And what about c equal to 3? Yes, it belongs to interval 2, 4. In fact, it is centermost value. It's arithmetic mean. Because what is the mean of 2 and 4? Mean of 2 and 4 is 2 plus 4 what means 3. So write here x equal to c equal to 3 belongs to open interval 2, 4. That means for that value of x, Lagrange's mean value theorem holds. Therefore, LMVT holds or satisfies for x equal to 3. Let's have an idea of this problem. Geometry. You need not do it in every problem. It is just an extra information I am telling. Let's analyze the same problem geometrically. Geometrically, what Lagrange's theorem says at point x equal to c. That means now at point x equal to 3, there will be a tangent which is parallel to the chord joining the points a and b. Very first, we have the curve. What curve? Y equal to x square. It is just like x square equal to 4ay time. Means it is a parabola shape opening upwards. What are you studying? It is roughly, not with 100% accuracy. Roughly. An interval. What's interval? 2 to 4. This is x equal to 2. This is say x equal to 4. This is say our parabola. Say this is point A, say this is point B. Now this will be called EV. It is called EV of parabola. Now at point x equal to 3, observe x equal to 3 will not come before 2, after 4, exactly in between 2 and 4. This is somewhere, because I am not using graph, I am using just a board. It will be approximate graph, may not be the 100% accuracy. That means the corresponding here we have x equal to 3. At this point, you draw the tangent. That tangent will be certainly parallel to that chord. This is tangent. This is chord. What you can observe? You can observe that tangent, chord are parallel. They have to be parallel because our function satisfying Lagrange's mean value theorem at point x equal to 3. Next problem. I hope you got this problem idea. Next question. Verify mean value theorem for the function. Verify mean value theorem for the function. F of x equals to x square minus 4x minus 3 on the interval 1, 4. Solution. Here A 1, B 4, f of x square minus 4x minus 3 curve 1. Let's find the f of A, f of B value. F of A, that is f of 1, 1 square 1, 4 into 1 4, minus 3 remains same. 1 minus 4 minus 3, minus 3 minus 3 minus 6. Also, f of b means f of 4, 4 square minus 4 into 4 minus 3, 4 square 16, 4 into 4 16, minus 3 remains unchanged. 16 minus 16 cancels, leaving out minus 3. And easily we can observe that. What you can observe is that f of 1 minus 6, f of 4 minus 3, they are very clearly not equal. Clearly, f of 1 not equal to f of 4. That means we need to apply Lagrange's theorem rather than Rolle's theorem. If f of 1 equal to f of 4, obviously Lagrange's theorem will transfer to Rolle's theorem. At that time, you must take f dash of c equal to 0. Now let's differentiate 1. Next step, differentiating 1 with respect to x. F dash x, right hand side 2x minus 4. What we can have very clearly, f dash x exists. No question of 0 by 0 form. Right? Clearly, f dash x exists. Also at the same time you can write down yourself which implies f dash of c. It's not necessary to say every time. You have to manage it yourself. F dash of c becomes 2c minus 4. So very clearly f dash of x exists. Therefore f of x is differentiable. That is differentiable on open interval a comma means here 1 comma 4. And every differentiable function is always continuous. Therefore, f of x is continuous. But for continuity, we have to take the closed interval. On the closed interval AB means the closed interval 1 comma 4. So let's implement Lagrange's mean value theorem because f of a not equal to f of b condition is satisfied. Now right, by LMVT we have by LMVT we have f dash of c equal to f of b minus f of a divided by b minus a. That is f dash of c means 2c minus 4 equal to f of b means f of 4 minus f of a means f of 1 by 4 minus 1 or 2c minus 4 equal to f of 4 value we found as in the earlier steps minus 3 minus f of 1 minus 6 divided by 4 minus 1 is 3. Further, 2c minus 4 equals to minus 3 minus of minus plus 6 by 3 or 2c minus 4 equal to 6 minus 3 is 3 divided by 3. 2c minus 4 equal to 1, 2c equal to 4 plus 1, 1 plus 4, both are same, 2c equal to 5, c equal to 5 divided by 2, 5 by 2, 2.5, which is exactly centermost value of 1 and 4, that belong to the interval 1 comma 4. That you must write. Write that here x equal to c equal to 5 by 2 belongs to open interval 1 comma 4. That means for this value of x, Lagrange's theorem will be satisfied. Therefore, LMVT holds. Holds means satisfies. LMVT holds for x equal to 500. That means for this curve on this interval there are number of points. At each point there is a tangent, and out of number of tangents at point x equal to 5/2, only at point x equal to 5/2 there will be a tangent. That tangent will be parallel to the chord joining the points x equal to 1 to x equal to 4. Still there are number of tangents in that, no doubt, but those tangents are not parallel to the chord. They may intersecting to the chord, but this is the only one point. That is x equal to 5 is the only one point at which tangent is parallel to the chord joining the points x equal to 1 to x equal to 4. Still we have some more examples. We shall meet in the next class. Another one more class we require. For these examples of this, we discuss some MCQ problems. I mean, multiple choice question based problems concerned to continuity of a function, along with some shortcut methods, etc. But after discussing some more examples on Lagrange's mean value theorem. Thank you. We continue in the next class.